In this example problem, we have another hypothesis test comparing the average of a sample to the true population mean to determine whether we think that the true population mean is actually different than the status quo. In this example, we have an alternate hypothesis that isn't less than or greater than, but it's not equal to. What is the scenario we have here? The research finds that today's undergraduate students study an average of 14 hours per week. A large university would like to test if the mean study time of its undergraduate students differs from the population average of 14 hours per week. And differs is the key word right here, because we're not saying it has to be lower or greater than respectively. It can be either, just as long as it's not what we're having as the going average. And this could be useful for a company that, internet company that puts out study guides for students to use, Chegs of the world, etc. Want to know how much time people spend actually studying during the period of time. In this case, we're trying to figure out if the actual average time of the population differs from the status quo of 14 hours that's accepted. We are going to form a hypothesis test at the 5% level of significance in this case, which means we are going to allot ourselves a 5% chance that we make a type 1 error, that we determine that we truly believe that the actual overall true population average that students study for a week is greater than 14, or is different from 14. And we find out after we get more information, a bigger sample of stuff, that that's not the case, that we made an error in assuming that the alternate hypothesis was true when we should have stuck with the status quo, the null hypothesis. So to figure out what our probability is in this case, we are going to have to go through and we are going to have to determine the points that we need to find our t statistic, our x bar, our mu, our s, and the n, the sample size. So let's start by figuring those out. The population average study time we have right here is the status quo. That's what's going right here. We are saying that the status quo right now says that the average student, all students, the whole entire population, is 14 hours per week. Well, we took a sample in this case to figure out if this is true based upon our sample. How big is our sample? Well, I can use the count a function to figure out how many students we have in our sample. And we have 35 students in our sample. So our n is going to be 35. What was the average study time for the students within this sample? Well, I could use the average function and grab the number of hours that each student studied during the week. So the entirety of cells B2 down to B36. And for these 35 students that we polled, they are studying on average 16.37 hours per week. So can we definitively say right now that yes, the whole entire population of students studies for more than 14 hours a week? Well, no, we can't, because we have a very small sample size of just 35 students. So let's take a little more information into account. Namely, what's the amount of variation that we have in our sample? What's our measure of dispersion, if you will? And we're going to do that by finding the standard deviation of these hours. So the stdev.s function is how you find the standard deviation of a sample. And I want it for all of the inputs. So cell B2 to cell B36. And when I run that out, I come up with 7.22. And now I have all of the information that I need to figure out my test statistic, my t statistic, if you will. I'm going to just fill in that formula that's given right here with the inputs that we just answered. The mean of the sample, the x bar, was 16.37 minus the accepted population average time that a student spends, which is 14, so x bar minus mu in the first set of parentheses, divided by the standard deviation of our sample, which is 7.22 hours. And we're going to divide that within those parentheses by the square root of our n, so sqrt, to use the square root function. Open a parenthesis, click that 35 for the square root, for the n that we have that we're finding the square root of, and then close both of the parentheses at the end. And when I do, I come up with a t statistic of 1.944. And now I need to figure out what type of probability I'm looking for. So again, we have our handy dandy little chart over here that tells us if we're a left-tailed test, a right-tailed test, or a two-tailed test. Left-tailed test would be if our alternate hypothesis is that it is less than the status quo, the accepted population average. That's not what we're testing for right here. A right-tailed test would be, in this case, the mean study time is greater than the status quo of 14. That's not what we're looking for either. What we're looking for here is that it's just not 14. It can be high or low. We don't care as long as it's not exactly equal to 14, and that is a two-tailed test. So when you're figuring out your probability over here, you want to use your t-distribution function for a two-tailed test. So I'm going to type in t.dist for my t-distribution. I'm going to hit go, and of the options that I have, we know we want a two-tailed test because our alternate hypothesis is not equal to. And I'm going to hit OK. And now I'm going to put my inputs in. The x is your t-statistic that you have. The degrees of freedom you have is always n minus 1. And I'm going to hit OK in this case. And I'm going to get 0.0602, which means that in this instance, if we reject this null hypothesis in favor of the alternate hypothesis, we make a firm claim in this case that the average student does not study for 14 hours a week. They study for a number that is different than that, either higher than low. We have a 6.02% chance of making a type 1 error, of declaring that that's the truth, getting more information than just these 35 students later to come up with a more accurate, set of information to make this determination, and realize we done made a mistake because we shouldn't have rejected Ho in the first place. So do we reject this null hypothesis? Well, it depends on what level of error we're allowing ourselves. We're allowing ourselves a 5% chance of making a type 1 error. Our information said that we had a 6.02% chance of making a type 1 error. So our P is not less than the allowable percentage that we had. P is not less than alpha. And when P is not less than alpha, you fail to reject the null hypothesis. We do not have statistical evidence in this case that students study for a different amount of time on average. The entire population of students studies at a different amount of time on average than the 14 hours that is the status quo. So we fail to reject the null hypothesis. Now, we're not saying that null hypothesis is the gospel truth right now. What we're saying is we don't have enough information to make that determination based upon these sample results that we had. And I don't know why I wrote it twice, but I guess for extra reinforcement, that's why we say no.